So you've seen what the course is about. We've sort of talked about it in general. Why are we interested? Why, in fact, would we even have a course devoted to solving problems? Why is it such a big thing? And the answer to that is very simple. It's because it's something we're not very good at doing. In fact, the software industry or software professionals, in a sense, haven't yet really solved the problem of writing software. You know, we use euphemisms like bugs for mistakes, and we are sort of relaxed about things not working or not getting in on time. And probably for your assignment in COMP2911 last year, quite a few of you might not have actually managed to get it working at the end of it. And in a sense, when we're doing technical stuff and the scientific sort of analytical stuff, that's okay, because you can still demonstrate you have technical skills, and you can still demonstrate that you understand the algorithms and the relationships and do appropriate analysis and make the right sort of choices. But you can see that that's not really much chop in the real world if we're actually writing software to solve a problem if we can't get it to work or if it doesn't come out on time. And, you know, I mean, people talk about this all the time. We can build bridges. They tend not to fall over. We can make cars reasonably well and aeroplanes reasonably well, and we can make solar panels that sort of work all the time. But actually, we're not very good at writing software, even though there's who knows how many people in the world constantly writing this stuff. And we've been studying it now for quite a long time, certainly longer than we've been doing photovoltaics. We actually still, if we had a new problem come along, and you're in charge of assembling a team to write a program to solve the problem, you couldn't be confident that it was going to succeed, unless you had, you know, a bucket load of money, unless you were Google and you were prepared to put all your resources behind. Oh, even then, if it was a hard problem, you still couldn't be confident. It might be a gamble. It's weird, because we talk about engineering, and engineering normally is constructing reliable things out of unreliable components. But we're actually not very good at constructing software, reliable software that works. And so I'd just like to spend a moment or two dwelling on that and talking about that sort of thing. So in computing, most projects fail. More than half computing projects fail currently. Actually, the data I saw was from 2006 or 2005, so it's an unsubstantiated claim for currently. Maybe just miraculously everything's changed. Maybe now that we have Ruby on Rails and .NET, and maybe we're up to Web 2.2, and maybe now we've got Google Ajax stuff happening, and everyone, and maybe now that Sun and Oracle have had their union, maybe all the problems have gone away, and probably if I was to look up the statistics, all software projects work now.
So they'll go away when we do translucid.
They'll go away when we do translucid. Yeah. I like your evangelical dream, that's right. But you see, everyone has this evangelical dream. Maybe it's for translucid, or it's for Haskell, or it's for Java, or it's for OO, or it's for Smalltalk, or it's for this, or it's for that, or it's for JavaScript of all things. But actually, the problem just stays there. It's never gone away. It's been there all my life. I don't think it's got better, and it's still there now. So let's look at this. We're designers. We're going to solve problems, come up with solutions for problems, and we're not very good at doing it. So in the previous course, this is the sort of taxonomy we had. Do you remember the PAPP I used to use as a mnemonic to remind you about the sort of structure? We said we have problems, and then we have algorithms, and then we have programs, and we have processes. So we have to solve a problem, so we pick an algorithm, and we implement a program, moving this way, implement, pick or design, make our own maybe. Then we run it, and we get a process. And hopefully the result of executing that process in the environment, in the target environment, is to solve the original problem. And this is the sort of way we were doing the last course, 1927, because we were really interested in the relationship at these are sort of different levels of abstraction. We were looking at what's the relationship between a problem and algorithms which solve it. And we found some interesting things. And we were looking at what's the relationship between algorithms and, I guess, processes, really, runtime, memory use, and so on. Are there ways of classifying algorithms by the effects they have down here? And we were interested in quantifying these relationships, and we found big O, and we talked about P and NP and all that sort of stuff. And we're interested in discussing these relationships. But I should point out right now that all of that stuff is fine when we're talking about sorting or searching, because they are small, self-contained, well-defined problems that have had heaps and heaps of analysis, and we've found real scientific and interesting results about them. But they're small problems. It's not as though Google's going to set up a team to write something to sort some numbers. That is a small, programming in the small, it's a small scale problem. For a real world problem, for a large problem, this isn't actually a very useful way of thinking about things. Suppose your problem is, well, I said Google. As you know, Google is trying to control all the information in the whole world and make money from it. Monetize it, sorry. So you're Google and you want to make something called Google Games. And what Google Games is they will have, just like Google's digitizing every book in the whole universe now, they're going to digitize every single game in the whole universe. And any game you've ever played, you could just go to Google Games and play it. Monopoly, chess, anything. It's awesome, what a great idea. And you're in charge of the team writing Google Games. So you're going to write a web sort of thing that lets people pick a game and then play a game, any game. And the game's got to be just fantastic, and maybe it's a multiplayer game, so there's got to be communication. Maybe there's elaborate graphics that have to be good, maybe there's sound effects, maybe it's against AIs, maybe it's players against each other, maybe there's people can write little robots to play strategies in the game. I don't know, what are you going to do? So you're sitting down in your whiteboarded room, bouncing on your bouncy ball, thinking, brainstorming, how are we going to write Google Games? Now, it's not a matter of saying, well, first of all, we have to pick an algorithm. We have to find the Google Game algorithm. There will be algorithms involved. Every game will involve sorting and searching and hundreds of little problems to solve this big problem. And those problems will have well-known algorithms to solve them, and we'll be able to look at how to implement those in code. But the real problem isn't implementing algorithms, and the real problem isn't running the processes. The real problem here is working out what the heck we're actually going to do. How are we even going to do Google Games? So let's just pick one game. Suppose Google have some game which is the guy that runs Google. What's his name again? Gary. Gary Google. And Gary says, look, I've got this game my kids have been playing. I love it. It's about ancient Rome. And he lifts the lid off the box. It's got all these cards with pictures of Romans on it. And it's got lots of dice and cards and discs and things. I want to play it on the internet. I want everyone to be able to play it on the internet. I don't want anyone to have to buy this game from now on. I want them to play it on Google and pay me because it's a good game. And he says to you, take this box and put it on the internet. So you're now, okay, so you're all bouncing around, you're just brainstorming. You're going to do the design thing now. So you're going, okay, what are we going to do? We're going to keep the rules the same. We're going to simplify the rules. We're going to add more rules. We're going to make the games that people can vote for rules while they're playing the game and add new rules. We'll make it a Web 2.0 game where the game can evolve over time. We'll let people save games and replay games. Maybe we'll have an AI that they can play against. Maybe we'll have teams of AIs they can play against. Maybe we'll rank the teams against it. Maybe the AIs will learn from playing from people and they'll get better and better. Or maybe people can just play two-player games. Or maybe it's just a one-player game and you have to get up and the other person sits down and makes their move, then they get up, and then you sit down and make your move. Maybe you can play with people in other countries. Maybe you can have it constantly do, oh, this is so exciting. So you think, what are we going to do? What are we going to do? And all you know is that Gary Google needs this out by June 30. Now, what is likely to happen 9 times out of 10 if this was actually a real-world scenario, but you weren't at Google, you're at some other place?
It would like escalate.
It'll escalate. It'll escalate in terms of features. It'll start getting depressing and messy. You'll all be excited and having great ideas and writing on the whiteboards a lot for the first 3 months, and then everyone will be very depressed and stressed for the last 3 months and no one will be sleeping. What will happen when June the 30th rolls around?
Nothing will work.
Nothing will work. But you'll have lots of stuff on the whiteboards. Look, it's so close. I can show you a mock-up of what it'll look like. And don't press that button now. And but you know, you'll have something that's almost there. And Gary Google will be disappointed and he'll say, oh, okay, I'll come back. When will I come back? And you'll say, next week. And he said, I'll come back in 2 weeks. And when he comes back in 2 weeks, what's going to happen?
Nothing.
Nothing's going to work. And okay, this is the world of software. That's what would normally happen. But that's not what we want to happen. So the issue isn't the relationship between the problem and the algorithm, because that's good for small problems. The issue is we have a very large, I'm going to draw a big P, very large problem. And I'm going to draw it sort of wavy because it's not ill-defined. He doesn't really even know what he wants. He just wants you to put this game on the internet. And even if he tells you precisely what he wants and he writes it down and gives you a precise description of exactly what you have to do, what's going to happen the first time he walks into the office? Maybe 30 March. He walks in on 30 March and says, show me what you're doing. You show him all the whiteboard scribbles and everything, and he says, you know, this game would be better if there was 7 dice. And you go, but you said here in this document here that there's just, no, yeah, I know I said that, but can you add another dice? I think that'd be awesome. So the spec will change. And every time he walks in, the spec is going to change. So this is a problem we face with. Large, ill-defined problems that are going to change over the duration of us working on them. It's not like uni where we give you a spec once and never change it. It's constant. It's going to constantly evolve and change. And at the end, we want some fantastic solution to that problem. And the danger is it's either going to be a fantastic solution to the problem or it's going to be big explosion. And nothing happening. Oh, maybe it's more fizz. Okay. All right, so that's our dilemma. That's what we're interested in this course. At the end of this course, I want it to be the case that someone could come to you and say, Gary literally could come to you and say, take this game, put it on the internet, make it fantastic. I'll see you on the 30th of June. And when the 30th of June comes and he walks in, you will say, here is your game. Now, we have this dilemma, and it will work, and it will be beautiful. We have this dilemma that if this problem is ill-defined and the client is free to change it whenever they want, and you have a fixed number of resources to work on the problem, like there's you and your mate and this many hours you've got to devote to it, you've got a fixed amount of computers and all that sort of stuff, and the deadline is fixed, you can't change it, and he can change the problem whatever he wants, what's going to happen? What's the tension we've got here?
He wants something else.
Yeah, even if you manage to work out how to squeeze it all in, he'll want something else. And he won't be satisfied. If you give him something, that'll just get him all excited, and he'll want something else and something else. And the amount of work will expand and quickly overflow. So we've got this process where what we have to do can change at any time, but our resources to deal with it are going to be fixed, and our deadline's going to be fixed. So how can we, this describes real-world software engineering. So how can we solve that problem? There's a well-known way of solving that problem. We've even talked about it before, but you might not remember. Does anyone remember? What's that? Solve a different problem. Yeah, yeah. What you do is you say, I will give you, on the 30th of June, the best I can. I will give you perfectly written code that implements a subset of the game perfectly well, and you will be able to play it on the 30th of June, and it will be great. But I can't guarantee that I'm going to be able to do everything. So in other words, because your options basically are, in this famous problem, either generate extra resources by staying up overnight all the time, but that's not the way to a happy life because this problem will never go away and you'll always be staying up and you'll never sleep, so that's no good. Or drop the quality of what you do. So just write shonky code and get it out really quick, which might give him something that looks like it works, but as soon as anyone wants to change it or as soon as someone from Russia uses it or anything like that, boom, it's gone and your computer's been taken over. So you can't change the quality. We want the quality to be high. And why do we want the quality to be high? Why is it that when we write software, we want to write really good quality software? We want the craftsmanship to be good. Why is that? Because that seems to be a waste of time. Why do we want good craftsmanship?
So you don't get running at 2 in the morning for years to come?
It solves problems down the line? Yes. Why else do we want to do good craftsmanship? So someone else what? So we're not indispensable, so someone else can take over. So that, from the business point of view, it makes more sense. You write good code, you're not depending on one particular person. This thing is maintainable and usable. It's not like disposable software. Let me tell you a story. Every semester, have you guys ever done anything called spots? Now, in my memory, every semester I've taught first year programming, to get the students to do unit testing, I have had a spot system. And I always ask a really smart person to implement the spot system. And every year I have the same conversation, which starts like this. You did the course last year, you hated spots, you're really smart, we've got the spot system, I want to do it again, can you just fix up the code so it's good? You look at the code and you say, I know, Richard, you know what I'll do? That code's not quite good enough to work on. I'm going to throw it away and write a new one. But it's going to be good. I say, the assignment's out on the 30th of March. Okay, they're going to need it from the 30th of March. You'll be all right? Yeah, man, it'll be fine. And every semester, you would think after a while, You know the story about the man and the dog. I think I've told you that if a dog bites a man, the dog should be shot. But if the same dog bites the same man in the same circumstances twice, the man should be shot. So after a while I'm thinking, I've heard this conversation before, but I believe you. I don't know why. So you do it, and the spot system never comes out on time. It never, and this is no disrespect to the people that write the spot system, they are the smartest people I know, but it never comes out on time. It always comes out about a week and a half late. Now, you guys have been using the spot system. What impact did it have on you that for the first week and a half of you using it, it didn't work properly? Can you describe that in sounds? It's annoying beyond all belief. It is just soul destroying for everyone. And then even when it does work, and it is running, it doesn't work properly, there's still problems with it. And probably by the very last time the last student lodges the last submission, maybe 2 days after that I'll get a phone call from the implementer saying, hey, it's all working now. And I think, oh, that's good. Maybe we can use it next year. But I know what's going to happen when I show it to someone next year and say, can we use this again? But it's too late, we've missed the deadline. So this is always the case that we want our code to be really high quality so other people can take it up and use it. We don't want to have the rewrite problem, which started that rant of mine, which turned into a lateness rant. And I'm the world's worst. Can we just make it really clear that in nothing I'm saying here am I criticising anyone less than I'm criticising myself. I am the most late person in the world. And there's no point in doing something late, even if you do a brilliant job, if it's late. Sometimes it's okay, but often it undermines the whole point of the thing. So, yeah, okay. So we have this thing that we want to do good quality coding because it's reusable by other people. And the software can be built on. It's not disposable software that has to be rewritten every semester. It's a system that can be built. That makes sense, doesn't it? Not to throw things away. We want to do it because, what was your reason again?
We don't want to get working at 2 in the morning.
Yes, it's annoying when there's problems. And if you want to think about it, is it better to get a problem at compile time when the design team is there and they're awake and it's the middle of the day? Or is it better to discover the problem at runtime when 9 million users discover the problem simultaneously and all ring you up? That's what we call a distributed reflected denial of service attack. The best time to solve the problem is when you've got it. It actually causes you much more work if it ships with the problem in. So yeah, so there are 3, if I remember right, good reasons, but there's an even better one. Why do we want to write good quality software? Yeah.
We want to be proud of it.
We want to be proud of it. We're not monkeys. We're writing software for the rest of our lives only if it's a good way of spending the rest of our lives. So we want to write stuff we're proud of. We want to do workmanship. Whenever I see a builder, I always ask them, I literally do this, whenever I'm in conversation with them, what do you think of it? What's your job like? Is it a good job? And they always say, or 9 times out of 10, they say, I love my job. I get to make stuff, I get to be outside, and I can drive around, and I can see stuff I've made. And they're really proud of it, and they're trying to do a good job. And that's the same with us. If we're really proud of what we're doing and we want to make good quality stuff, we're really motivated and life's really good. If we're depressed with what we're doing, if we're running crap stuff in a hurry, then we get the, it's sort of, on a personal level, it's unsatisfying. So we want the quality to be good, So the only thing we've got to move on is the features. So that's what we move on. And we don't just drop features willy-nilly or randomly. We cleverly select the features we think are most important and we do those ones first. So we say, okay, Gary, you want this entire game on the internet. That's fantastic. I think, first of all, I'll just make it a one-player game and I'll just get the rules working. And he says, yeah, that's fun. The rules are really fun. And then you say to him, okay, Gary, I've got the rules working and it's a one-player game that's a bit boring with having to move away from the computer and step back. What's the next best thing about it? What do you like about the game? And he says, oh, I don't know. And you say, well, I could make the graphics fantastic or I could make it a 2-player game so 2 different people on different computers could play it networking with each other. And he says, I like the pictures of the Romans. So you say, okay, so you do this fantastic graphics next. And then you finish the graphics and you've still got 4 weeks to go and you go, oh, what do we do next? We could make it multiplayer or you could play against an AI. Or we could do this or that. And he says, no, make it multiplayer. Make it multiplayer. So you do that, and then after that you say what to do. And sound effects is what I like next the most. So every time he's picking what he likes the most, and then you're delivering it, and then you're adding more features. So when the deadline rolls around, what you deliver actually works, and it's fantastic, and you're proud of it. And it's just not everything that they want, because no one can give them everything they want, okay? If someone can just invent specs, they're going to invent a spec that's way too hard for you to ever implement. Is that cool? So that's this is called Agile programming. XP is an example of that, and that's what we're using in this course. Yeah?
At the start, isn't he just going to say, that's all well and good, but when are you going to get the whole thing done?
You explain to him what you're doing. Yeah, the question was, won't they just want the whole thing? I think a businessman wouldn't want the whole thing, because a businessman understands you can't have everything. There's got to be trade-offs. You don't want the trade-off to be in quality. Maybe that's the hardest argument to make if they haven't experienced. No, I think by now everyone's been around long enough and experienced bad software that everyone knows about. The development cost of software is a small, in the total life cycle of the software, it's a small amount of the cost. So a businessman, you've got to say, but then we have to support it downstream, and da, da, da. So I think you could make the economics argument of writing good stuff first, and then you say, these are my finite resources, this is what I can do. I think if I was a businessman, I would actually like that. In fact, I used to be a businessman years ago, and I used to delegate work to underlings in the office. And there was one girl who was ferocious. And I'd give her work and I'd say, I need a report on this and we need to summarise all that. And I'd try and creep away. And she'd go, no, no, tell me more. And she'd really pin me down about what I really wanted. And then I'd go away and she'd come back an hour later always and say, I've sat down and I've done estimates and I can do this, this and this by that deadline, but I don't think I've got time to do that. And I actually, after a while, grew to really love her. In a fun way, because she always did what she said she'd do, and I'd just get someone else to work on that problem, and it wouldn't be a nightmarish surprise at the end. So I think your boss would sort of, sure they want everything, but if you explain to them they can't have everything, I think what they're getting is the best they can get then, which is the features they want the most working, rather than 90% of everything with nothing working. But yeah, it's an argument you have to make. What other people think? Yes? Get a good boss. That's a clever idea. Manage up, I always think. Make sure you work. If someone really wants you to work really hard and deliver everything in its cross if you can't do the impossible, it's going to destroy your heart after a while. Has anyone worked for a bad project manager ever? Oh, yeah, that's what you're saying, get a good project manager. Tell us a story. Tell us a story. What happened?
I used to work in publishing in tech journalism.
Yes.
We were always chasing deadlines.
Yes.
And there were times when the kind of quality that I wanted to put into the magazine, it just wasn't feasible.
Yes.
At that kind of time. And we could never agree on what I wanted to write
Yes.
versus the deadline for the magazine, which could be pushed because
Yes.
you can rearrange
Yes.
how you publish content.
So you were writing stuff you weren't happy with in the end, or you just weren't sleeping?
I wasn't sleeping.
All right, so this is exactly the scenario we were talking about before. He wants to do good quality work. They've got a deadline that's not very flexible, and the boss wants too much done. You can't deliver that much at the quality you want in the time he wants. So something's got to give. And what gave?
Me.
You gave, yeah. See, ultimately, that's not good for the boss either. So I think the boss would be happy if he knew he wasn't going to burn his stuff out and he could keep stuff. Okay, so that's our problem. Now, one more thing to talk about, just about this whole general problem. We've got this big problem. We're going to write some software which is hopefully going to solve it. I'm going to draw where the people are in this picture, because at the moment there's no people. We've got users, we've got programmers, and we've got the people giving us the problem, the client. The client's going to give us a poorly specified description of what to do, and it's going to change. A group of programmers, because it's a big job, is going to have to work together to deliver it. At the end, the users are going to like it or not like it. Now, it turns out that a lot of the reason that the whole process doesn't work is that we're not very good at managing a group of people. So if you write a small program, you can write it by yourself. If you write a big program, you've got to write it in a team. And writing in a team is really hard, especially if you're an individualistic computer programmer that just is the best person in the world and think you're the best person in the world and you write the best code in the world and you don't want anyone else to look at it or touch it or question it. So managing the whole group work thing is really important to solve problems, because if you don't have the team all working together, then you're not going to be able to write the software if it's a non-trivial size. So in this course, now summary of the course, we're going to be looking at the whole process to give us solutions. I know it sounds like jargon and crap when I say it, okay? Solution is a horrible word, but we're going to, and process is a horrible word now I think about it. It sounds like management speak. But we've got a problem, we want to solve it. That's our solution. And we've got to work out how we can do that. That's the process. And we're engineers and we want it to be something that's going to work and be reliable and not just work if we're lucky, but sort of always work. And to do this, it's going to have to involve a group of people. So we're going to, in this course, be looking at the process of going from here to here, which is going to involve, first of all, checking you got the right spec from the person and that you're solving the right problem. Easy mistake to make, number one. Number two is then, how do we manage the people to write the software? How do we make people fit together in a sensible and productive way? And the last thing is, how do we actually write this piece of software? Because it's bigger and scarier and more lines in it than anything you've seen or dreamed of so far. But it has to work just as well as the small little self-contained things you hand in as assignments work really beautifully. We want this thing to be like a piece of clockwork and work beautifully too. So we're just going to use our common sense skeptical skills and talk a lot about design and look at design and other disciplines to try and get a handle on how we understand the problem and how we can deal with a poorly specified problem that keeps moving around, how we can solve the right problem. We're going to look at this technique called Agile programming. I don't even know how to spell it. G, I guess. Is it G? A-G-I-L-E, thank you. We're going to look at Agile programming, which is a way of getting a group of people to fit together and deliver a piece of software. And then we're going to look at how to arrange all the bits of software together to make them solve the big problem. And to do that, we're going to be using, as you can see from this picture, OO, object-oriented programming. So they're the sort of three parts to this course that we'll be doing. Okay, let's start writing some code. Oh, actually, let's just do some admin stuff first of all. Here's what you've got to do in the first week in case you haven't done it yet. Let's just go to the home page for the course. There's a warm-up tutorial in the first week. Here's how the course is going to work this semester. Your final assessment is broken into 3 parts. And your final assessment is the average of these 3 parts. And we use the harmonic mean of the 3 parts, which means if you do crap in any one of them, you do crap overall. That's really mean. That's why it's called the mean. And the 3 parts are equally, the final exam is worth 1 part. You do a big project, that's another part. And you get a mark for doing some tasks, some lab work over the year, that's the other part. And your final mark is just the average of those 3 parts, the harmonic mean. The final exam has some interesting parts to it, but let me just tell you now, it's a theory exam followed by a prac exam. And the prac exam is really easy, and the prac exam's a hurdle. And the prac exam is based 100% on your project. The prac exam and the final exam is done solo, but everything else in the course isn't. Then there's the tasks you do each week. Now, I looked at the course 1927 last year, and I thought we had too much assessment. There's too much stuff happening. It was very, very confusing. We had tutes and labs, and we had exercises, and we had multiple assignments, and it was very, very confusing. So, we've got rid of the multiple assignments, we've only got 1. We've got rid of all tute and lab exercises. So, when you go to the tutes and labs, you just sit around talking, and you have clipboards, and you talk about design patterns. And you can just say rubbish, and no one will know. It's fantastic. So all you do each week now is something called a design task. And every week you get a design task. And you could think of it as a lab exercise if you want. You're going to do your design task in a pair. Everything's going to be done in pairs. Because the method of Agile programming we'll be using, XP, involves pair programming. Pair programming means 2 people, 1 computer, 1 keyboard, 1 mouse. 2 eyes, 2 brains, 1 person talking, 1 person typing, looking, discussing, interacting with each other. Every single thing you do in the course, except the final exam, will be pair programming. For your tasks, so you get exposed to different... Pair programming is fantastic, slightly threatening and scary when you first do it. It's the best way of improving the quality of your code. I want you to be exposed to as many other programmers as possible so you can all learn from each other. So each Platipiad, and how long does a Platipiad last for? 4 weeks, a third of the course. So each Platipiad you'll get a new partner to program with for your tasks. They're called design tasks, so this is called your design partner. So you'll have 3 of them over the course. There'll all be someone from your lab, and what you'll do is you'll sit down in the lab together and you'll work on the design task for that week. The design task in week 1.0 is called task 1.0. Okay, you got it. They are all due, except for the first task, which is due next Monday, they're all due on the Friday of the week they relate to. In fact, we're having no deadlines in the middle of public holidays. Oh, except I think I left a Monday deadline in there by mistake over Easter. But All the deadlines are in working hours on Monday to Friday. So there's no more late nights and things like that. So it's a Friday afternoon thing. There are no extensions whatsoever for any reason. You can come to me with a story though, because it'll be, I'd like to hear it. But basically the deadlines are deadlines are deadlines are deadlines. They are Gary time. Gary's coming. You can't say, Gary, I'm nearly finished. Can you come back in 10 minutes? Because that'll go down on your permanent record. That's not very good. So design tasks every week, do them in your pair, sit in the lab doing them. You've got 2 hours in the lab to do it. I reckon they'll probably take 3 hours if you want to get a credit standard for it. So you'll spend an hour together with your partner. So make sure you exchange details with your partner and spend another hour sometime in the week. And you get, or longer if you need it. And there's just one task to do every single week. There's 12 tasks over the course. And you don't need to do all the tasks to get full marks and all that. But you have to get close to all of them to get it. So that's it. So the design task is replacing all student lab exercises. And then we've got rid of the small assignments and we just left the big project in there. And you know what I was sad about in 19127 was that a lot of people got to the end and were very, very close. And they had good code that was 99% there. But do we want that? What would I rather see?
Half as good all the way there. Half as much all the way there.
Half as ambitious all the way there. So there's every single week, after a couple of weeks, you will be releasing your software. You'll make a public release of your software and it has to work. And you'll slowly add features each week. There's a release time. If you don't release it by the release time, it's late. It's 0. It doesn't count. So there's that deadline, get it in before the release time. It doesn't matter if you don't get it in, you just lose some lateness marks, or the marks for that thing. But I don't want people coming saying, oh, I've got to do a review, I'd like an extra week, or Our part of that bargain is we get everything else out to you nice and early, so you have plenty of time to do it. But then you have to manage your own time, and you have to make sure it is all in on time with not a single extension. And I think we've already had one extension request to which the answer is no. Someone had to go and see their grandma or something like that, or had a job or something. No, no, no! Don't see your grandma, because it could be scary travelling to your grandma's, and check her when you get there in case it isn't really her. That's all I can say. Okay, so you understand the tasks, and you understand the final exam. The only thing left to understand is the project. And the project is this. We're going to give you a game. And the game is called Roma. It comes in a box. It's gorgeous. And there's pictures of Romans inside it. It's just fantastic. And I want a fantastic game. Hi, Gary. Call me Gary. Now, every week you're going to do a new release. So in week 2.1, what release of the software are you going to be making? Version 2.1. It has to work. You can't make a release that doesn't work, but you add new features each time. And every time you do a release, you just give us a what's new, release notes. So you tell us what's new, bugs fixed, known bugs, what's been added, what your intentions are for next time. We will mark your final one, which will be version 3.2, though you are to imagine that the whole thing is running to version 5. So you will not be able to put every feature in that you want. Just for each release, add the feature that you think is the best and most important for the next one. Does that make sense? In the past, when we've had projects, like for example, 1927, what was our project? Dracula. Yeah, okay. So what happens is I sit down and I play the game, and then I think, oh, these rules are too complicated, so I'll give you a simplified version of the rules. And then I think, oh, how will we do it? Will we have multiplayer? Will we do this? And I set that up, and I design interfaces, and I design how it all fits together. And then I give you one interface to implement yourself, but I do everything else and set it up, and then I say, you go away and write the little bits of code to make this work. And that's really fun. I enjoy doing that. But who's doing the design work there? Me. I'm deciding what the game should be, what it shouldn't be. This is a design assignment. So I'm giving you the box. I'm not even giving you the box. I'm giving you the name of the game. You can get the box if you want, or I'm giving you a link actually to the site where all the rules and everything else, so you don't need to get the box. You go there and work it out and play it, and you'll work out how you're going to do the game. And you'll work out with your partner, your pair programming partner, well, I think first of all we should play a single person game and just get the rules working. And then we'll try and make it 2 people. And I hate graphics. And your partner might say, I hate graphics. And think, well, we'll do a low graphics version of the game. Okay, so on and so on. Throughout the course, we'll teach you a little bit of graphics, a little bit of GUI, a little bit of networking. So if you want to have any of those things in it, you're welcome to put them in. But you don't have to. Completely up to you. So that are the 3 parts of your assessment. And the reason I'm telling you about that is, shh, 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 shh. This week we're having a warm-up tute. And in the warm-up tute, All that's happening is you get to know your tutor, you get to get a bit of admin stuff out of the way, but it's fine if you don't do it because you can do it the next week, and your tutor starts to form the pairs. You don't have to come. Your tutor will work out the pairs in your absence. If you don't come, that's fine. These are the pairs for the design tasks from each week. The pairs for the project though, I don't know. I keep thinking about it. Last year we went to a lot of effort to try and form teams of people that were equal. Well, every tutor did a different thing actually. But some tutors went to a lot of effort to try and work out teams of people that were equally motivated. Some tutors let the students pick their own teams. Some tutors let the students do random teams. And I always wanted to ask you guys which ones worked, but I was too disorganised at the end of the semester to ask properly, so I thought, oh, I'll wait till the next course comes along. So you guys tell me now, what do you reckon the best way of picking your project partner is? Should it be you guys get to pick? Let's have a yes. Who thinks yes? Put up your hands. Yes, let me do summaries, advantages and disadvantages. Advantages are, you know the person already. And you know how to contact them. And maybe even know where they live if they're your friend. Disadvantages are, oh, you're voting yes or you got something to say?
We have them not from the same tube.
No, you can't have them not from the same tube. No. But you can move tubes to be together. But disadvantages are, if your friend's a dick and not pulling their weight, it can actually ruin your friendship. And I actually am strongly against people doing it with their friends from my own theoretical point of view, but you're welcome to pick it yourself if that's what you want. But I've seen, oh, John, have you ever programmed with a friend?
Actually, I had a bad experience in OS with my friend.
Oh, yeah, your friend was a dick.
No. Well, it was,
Oh, that was Rupert though, wasn't it?
that was iOS.
Oh, that was iOS. Oh, yeah.
We just had he was away one weekend, and we started the assignment late, and then I had to start. It was going to exam period. I had my birthday. It was my birthday, but had the exam, studying for exams, and so he left him doing something. Basically, it was not good. He's friends with me now, but like there was 6 months of awkwardness.
6 months of awkwardness. Yeah.
That's why I was Rupert.
Yeah. That's right. So it can put a strain on your friendship, and I think also your friend is already likely to know how you program, and you're already likely to know how they program, and I'd quite like you to be exposed to other people. But you know, that's not a bad idea, picking yourself. Another idea is doing it randomly. Who likes a random idea? Also, you might not have friends in your tutor, and then the people. Why do you like the random idea? Just because you don't know people? Yeah. So what tutor are you in? Tomorrow. Who's taking tomorrow's Wednesday? Is that Rupert?
I'm taking the morning one.
Are you in the morning? Yeah. So what's your name? John. So John will be in your tutor. So Rupert will look after you. He'll make sure you're okay. Yeah. Random's okay. Another way of doing it is by, I think the most successful way, by the way, is working out how much effort people are prepared to put in and pairing you up with someone that's going to do the same effort. So if you're lazy and they're lazy, it's a marriage made in heaven. If you're a working maniac and they're a working maniac, it works really well. Even if you're different abilities, it doesn't matter. You're both happy because you're working like maniacs. But what doesn't work is if one of you is lazy and one of you is a working maniac, that leads to 6 months in Siberia. So that's not so good. So how do you want to do it? One way is tutors could do it by your marks from last year. Yeah. No. Makes it easy for them. Yeah. I've forgotten your name. Chen? C-H-E-N. Yeah. Chen.
What happens if you do something like you pick a person out of a few people who share the same motivation as you, so you get a bit of both?
Okay. So one thing we could do is get people to divide into motivation groups, like those that are really, really going to work hard, and then within the motivation groups, you could pick someone within there. I don't know. Would you guys want to vote on it? Do we want to have a vote? What mechanism should we even follow to come to a decision here? What's your idea?
I've seen a Japanese TV show just like
Yes.
and the way they try to find motivated people to do the project was actually by auction.
By auction? I've seen a Japanese TV show and they found motivated by people by how long they could stay on a slippery pole while giant bananas they're hitting them. I was thinking we could do that. I thought that's what you were going to say. I was excited. So by auction, how does the auction, people have to pay to be in the teams?
let's say we stand up and do some of the self-introduction and then
Yes.
Explain what I can do and what my skills are, and then other people put the beat and.
Oh, but you can feel sad if no one bid for you. Like, I'm just thinking, have you seen Groundhog Day? There's this scene in Groundhog Day. It's a very nice film, but there's this guy that gets up to the auction and no one puts a bid. Not that it would, I'm not saying it would happen to you. I'm actually thinking of me, remembering being picked for sporting teams and going home crying because no one wanted me in their team. I'll take Richard if I can take 6 other people as well. I can't say. So that's a good mechanism. But I just can't work out, it's not instantly apparent how we can make it work in a simple way. I like the idea of a protocol that works it out. Does anyone have other ideas? Yeah?
Set an impossible problem and see who takes the longest to try and solve it.
Who gives up first? Yeah, that's right. Okay. Oh, you have a warm-up exercise of some sort.
But then there's one exercise that they can't particularly do.
Yes. You might not tell you how hard they're prepared to work. They might just be lucky and just. But it's. All right. Well, here's what we'll do. Shh. Here's what we'll do. So this is Richard resuming to dictator rather than the democracy model that we nearly had just then. How about I give you a task to do for your next tute. You all do it, and then you can see who's really putting a lot of effort in and who isn't. And then your tutor forms a task based on that. And if there's someone you really don't want to be with, you slip your tutor a note saying, I really don't want to be with them. And here's the task. It's what I call show and tell. I have done this in a previous course. Show and tell goes like this. During the week, you look for some example of something that is brilliant design. Or you look for something that's an example of crap design. You bring it in, and in just 2 minutes, you explain to the class what it is and why it illustrates good or bad design. Example, I was driving here this morning. There was a power line down on a road, and all the cars were jammed and everything was stopped. And there was a bloke there holding a lollipop. You know those lollipops? Yeah. Now, the lollipop is a brilliant design, I realised as I was looking at him. I thought, oh, that's so clever. I wish I'd invented the lollipop. Because what's the problem when you're trying to control traffic manually? What's the worst thing, the thing you never want to happen?
To get run over.
You personally don't want to get run over. That's right. The safety of the operator, I hadn't thought of that. But for the traffic.
No signal.
No signal. Yeah, you don't want 2 cars in opposite directions.
Red on one side, green on the other.
Yes. You don't want 2 cars in opposite directions to both think it's okay to go. Because if someone tells you it's okay to go, you turn your brain off. Really, no signal is probably better than 2 green signals. Because no signal, you think, I'm on my own, it's the Wild West, you travel at 1 mile an hour, traffic goes really slow, but okay. But you don't want to have 2 greens. Now, I look at those automated signals all the time, or I look at train crossings. You ever see those automated train crossings where the road goes over a train and booms, and you think, ooh, what's the failure model for that? What could happen if that goes wrong? And it just makes me shiver to think. So I'm always looking both ways when I cross a train crossing, even if the thing's saying it's okay to go. So I'm thinking, normal traffic lights, what's the catastrophe that could happen with normal traffic lights? Because you whiz through those at high speed. Both green. Does anyone know how traffic lights are designed? Yeah. Yes, David does. Oh, no, but hang on. I've forgotten your name.
Dylan?
We'll let Dylan go. We'll do it in reverse alphabetical order.
Do you just mean like the timing?
The timing? No, not the timing. Does anyone else here know how traffic lights work? Yes. What's that? There's wires under the ground?
Yeah, and they sense where the car's on top.
And they sense where the car's on top? Yes, but the important feature that I'm looking for here to stop the catastrophe happening, which is 2 greens being on at the same time.
One can't be green while the other one's red.
One can't be green while the other one's red. See, it's just... that's an example of the spec changing. You know, you tell him the guy to build the thing, and then later on you go, did I say green? I meant red. And he goes, oh! Yeah. That's right. You don't want them both to be green at the same time.
The lights on the ones that it would be bad for are in series, so they have to both be, like, one must be red and one has to be green, or the other one.
No, because it can go orange or... But yeah, I like the way you're thinking of some designed to force it to happen. Yeah. Fancy. What's that?
Sound camera sort of thing?
There's a camera...
There's these cameras I've seen that say sound camera. I don't know how they work.
Yes.
Maybe that's how it works.
No, it's sounding clever to me, but it's sounding complicated. And as a designer, I'm thinking...
Judge by the amount of noise coming out of that specific area to make it a green, not a red light.
So they probably make good decisions about what's green and red. So they probably control traffic flow really well based on sound. That's really clever. I hadn't thought of that. But what I'm thinking of is just a catastrophe problem of green this way and green that way. As a designer, I think that's our first problem to deal with. You know, after we've solved that, then make the traffic lights as efficient as you can. But under no circumstances can they ever both be green, because if they are, someone will die. It's not a joke. Someone will die if they're both green. So, and it could be a kid or a baby. Have you ever seen those baby on board signs? I'm going all Seinfeld, but what's with the baby on board signs? It's like, I was driving along, I was waiting in traffic this morning, there's a baby on board sign. I'm thinking, what, I'm not going to ram you now? You've got to...
Do you mean in terms of like interlocks?
Interlocks. Yes, there's a mechanical, yes.
I don't know what the interlocks are, but obviously they've got interlocks.
There's an interlock. Interlock means it's physically impossible, the way they set it up, good traffic light design, is set up so it's physically impossible for both to be green on at the same time. Normally by a shorting wire that runs underneath, that if they both tried to go on at the same time, an electrical short would happen and the system would just explode or something. But the greens cannot physically be on at the same time. Now, of course, that wire could be cut and the thing won't work, but it's a physical device. It's not relying on some software. Oh, don't worry, Gary. I've done it in JavaScript with Ruby on Rails. There's no way both green lights can ever be on at the same time. Yes?
Everyone knows the best software interlocks are written by French-Canadian corporations.
Oh, okay, yes. No, we don't want to talk about that. Okay, yes. Okay. So this is what I liked about the traffic light sign. What am I going to say about the lollipop? Why did I think it was an amazing design? It's interlocked by default. Tell us what's happening.
No matter how lax the operator is, he can't screw it up. It has to be.
The operator cannot screw it up because
There's red on one side.
there's red on one side and green on the other. So if you just got one guy there holding this thing, there's no way he can turn it, unless he's so lax that he paints the red side green. So it's like what I think of as passive design. The system just works without something fancy happening to happen. So as I was driving in, I saw that and I thought, what a great example of good design. I wonder if I'll get a chance to mention that in the lecture. Lo and behold, I got to mention it. I actually stole it from the guy. Yeah, I'll bring it in tomorrow and show you. So that's my show and tell. So your challenge for next week and for each week, but everyone do it for next week, is to bring a show and tell along demonstrating good design or bad design, and so why it's good or bad. And you can put a lot of effort into this if you want, or none, and I don't care. But yeah, but your class will watch closely, and your tutor will watch closely, and maybe that can be the... What does everyone think of that as a basis for forming pairs? Nah, it's volatile, yeah.
Depends on how good the tutors are.
Depends how good the tutors are. Yeah, tutors are pretty crap this semester, actually. Yeah. What's that?
It's a lot of work how you present it, or is it?
No, it's just...
Which design is better?
No, well, this is a good question. Is it John? George. George has a good question, which is, what do I mean by a lot of work? Is it how you present it, or is it how clever the idea is? What's my answer going to be?
Whatever the tutor thinks, really.
No, I don't care. If you put a whole lot of work into making it really pretty and it's a stupid idea, then that's indicating you're someone in a team that's not going to write good software but is going to make the graphical interface really pretty. Yeah. I mean, whatever you do just sort of talks about you. If you have a brilliant idea but you come in late to the shoot with it, you're someone who's going to have brilliant ideas but going to give everyone a heart attack. Yeah, if you come in and say, I had this brilliant thing but I left it on the bus, or a bat ate it, or something like that. Okay. All right, now, we've got another half an hour. Let's take a little break, and then we'll resume for the final half an hour in a second.